Okay, welcome to the third video in the Introduction to R sequence. This is called Introduction to Functions. So sort of a classic coding interview problem is FizzBuzz, which is a problem that's given in code interviews to make sure that you can write code before as you're applying for the job. So the challenge in FizzBuzz is to take a list of numbers from 1 to some arbitrary number, n, for example, and for any multiples of 3, you want to print fizz instead of the number. For any multiples of 5, print buzz instead of the number. And for numbers which are multiples of both 3 and 5, print fizzbuzz. And then, just print the number if it's none of those. So let's define a function. So we're going to call this function fizzbuzz, and we're going to use variable assignment. So we're going to assign the function to the variable fizzbuzz, and then we're going to use the keyword function with n as an argument to the function. So this is how you create a function in R. We're going to create a function that's going to take a single argument n. And then we're going to put braces here, and what goes inside the braces is what the function is going to do. So what we're going to do first is we are going to loop over all the numbers from 1 to n. So we're going to do a for loop here and put parentheses, and we're going to say for I in range 1 colon n. And that's going to be our for loop. And let's verify that this is working. So let's just print I. We're just going to make sure that the print works right now. So let's run that, and then let's go ahead and test this out. We'll do fizzbuzz, and we'll just put in, say, up to 5 right now. And it looks like it is not doing exactly what I want it to do. And I can tell why. Because I went from 1 to n, I want to just go a range of n values. And let's run that again. That's not what I want. Okay, welcome to the third video in the Introduction to R sequence. This is called Introduction to Functions. And what we're going to be doing here is we're going to be writing a function called fizzbuzz that prints numbers from 1 to some arbitrary integer called n. And if the number itself is a multiple of 3, it should print fizz instead of the number. If it's a multiple of 5, it should print buzz instead of the number. If it's a multiple of both 3 and 5, it should print fizzbuzz instead of the number. This is a classic computer science coding interview problem. So we want a function named fizzbuzz. And so we're going to create a variable named fizzbuzz, and we're going to assign a function to it that's going to take an argument n. And then we put some braces here, and whatever goes in the braces are the substance of this function. So this is sort of your template for getting a function started. You have the name of the function, you assign the function to it, and the arguments that it takes go in parentheses right after this keyword function. So to get started, we are going to create a for loop, and we're going to go for I in we're making a vector from 1 to n, and we are going to loop over those values using this for loop. And then what the for loop is going to do, we're going to use braces again, and we're going to put the action that the for loop is going to take inside these braces. Now, just to make sure that it's working, let's put a print statement here, and we're going to print the I each time we pass through. So let's just test it out on a small number, say 5. And it looks like it's doing what we expect. We want it to just print the numbers right now. So the way that we're going to implement FizzBuzz is we're actually going to use an if statement. So if I modulo 15, which is 3 times 5, equals 0. So this is going to give us, this is going to be evaluate to true for all the multiples of both 3 and 5. And when that's true, we should print FizzBuzz. And then we're going to do else if, and we're going to put a second condition here. And now we're going to do I modulo 3 equal to 0. And this is going to give us, this is going to be true for all numbers that are multiples of 3. We are going to print fizz. We're going to do else if I modulo 5 is equal to 0, which will evaluate to true for all multiples of 5. It will be false for any of these that are not multiples of those numbers. We're going to put the braces here, and if it's a multiple of 5, we're going to print buzz. And then the final case, if it's none of those things, we want it to just print the number itself. And that's our FizzBuzz. Do we want a double modulo in R? We want a double modulo in R. Let's test it out up to 5. Okay, that looks good. Let's test it up to 15. Looking good. So the instructions here say that we should demonstrate that it works up to 50. So let's do that. FizzBuzz 50. And there it is. That is what we expected to do. Now, the challenge here, it says to identify at least 2 local variables in the FizzBuzz function. So let's go look at this function we defined here. So let's see. So we've actually, there are in fact 2 local variables. So we've got I that's used within the context of this function. It's used in the for loop. So each time we go through the for loop, I is going to be replaced with a different number. And then we've got n as well that's going to be used to set the range of numbers that we should go through. So each of those is a local variable. It's not defined outside of the function. It's only defined within the function. So we could put here I and n are local variables. And the way we could demonstrate that they are both local variables is we could try and see what they are. If we could put I here, and it says object I not found. That's because it's not defined. Even though we've run through the function and used I inside the function, it's not defined outside of the function. So we verified that it's a local variable. We can do the same thing with n, and we can see that it's not found. It hasn't been defined. It's a local variable. So what is a global variable? Well, a global variable is a variable that's defined in a global sense. So we actually really only have one global variable in this notebook, and that is the name for our FizzBuzz function itself. And I can put FizzBuzz right here. And you can see it is defined to be this function.